The auroras can be seen as they sit in the shadow of Jupiter. Astronomers have discovered new auroras over Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto, observable at visible wavelengths. The new auroras reveal in greater detail the composition of the thin atmospheres of these Jovian moons, including traces of oxygen and sodium, but only minimal water vapor. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. The team made the discovery while observing the moons as they sat in the shadow of Jupiter, the solar system's largest planet, using the Keck Observatory's high-resolution Echelle spectrometer, HIRES, as well as high-resolution spectrographs at the Large Binocular Telescope and Apache Point Observatory. The use of Jupiter's shadow as a sunshade allowed the scientists to see the faint auroras caused by Jupiter's powerful magnetic field without them being overwhelmed by bright sunlight reflected from the surface of the Galilean moons, named this because they were discovered by Galileo Galilei in the 1600s. These observations are tricky because, in Jupiter's shadow, the moons are nearly invisible, the lead author of one paper documenting the team's findings and California Institute of Technology Professor Catherine DeClaire said in a statement, opens in new tab. The light emitted by their faint auroras is the only confirmation that we've even pointed the telescope at the right place. The four Galilean moons all possess oxygen auroras the same as can be seen in the sky over Earth around our planet's poles. Yet, because gases on the Jovian moons are much thinner than on Earth, these auroras glow in deep red rather than the familiar green glow seen over Earth. On the moons Europa and Ganymede, which is the solar system's largest moon and bigger than the planet Mercury, oxygen auroras are also visible in infrared wavelengths, just outside the red end of the electromagnetic spectrum, and thus can't be seen with the human eye. This is the first time this particular phenomenon has been seen in the atmosphere of a celestial body other than our own planet. The aurora of Io is striped with a wide range of colors, likely arising from the fact that this Jovian moon is considered the most volcanically active body in the solar system. As a result of this violent volcanism, plumes of gas and dust are launched from Io's surface, reaching altitudes of hundreds of kilometers. These plumes contain salts like sodium chloride and potassium chloride, which break down to produce additional colors in Io's auroras. The range of colors includes a yellowy-orange glow that comes from sodium and an infrared aurora caused by potassium, which has never been detected anywhere else. The brightness of the different colors of aurora tell us what these moons' atmospheres are likely made up of, said DeClaire said in the statement. We find that molecular oxygen, just like what we breathe here on Earth, is likely the main constituent of the icy moon atmospheres. A lack of water vapor. Currently, scientists think that the three Galilean moons furthest from Jupiter, Callisto, Ganymede, and Europa, feature oceans of liquid water beneath their thick icy surfaces. There is also evidence that water in the atmosphere of Europa, believed to have twice as much water as Earth, may come from its subsurface ocean or liquid reservoirs within its ice shell. The team's observations have revealed only minimal traces of water vapor, a result that may impact the ongoing debate in astronomy of whether the atmospheres of the Jovian moons are rich with water molecules. Jupiter's magnetic field is tidal, meaning that the brightness of the auroras of the Galilean moons changes as the gas giant rotates. Additionally, the atmospheres of the moon react as the moons lose exposure to warm sunlight as they slip into the massive planet's shadow. The team was able to observe these changes, thus painting a more complete picture of the atmospheres of the Galilean moons. Io's sodium becomes very faint within 15 minutes of entering Jupiter's shadow, but it takes several hours to recover after it emerges into sunlight, Boston University professor of astronomy and lead author of the second paper, Carl Schmidt, said. These new characteristics are really insightful for understanding Io's atmospheric chemistry. It's neat that eclipses by Jupiter offer a natural experiment to learn how sunlight affects its atmosphere. Astronomers have spotted new aurorae at visible wavelengths on all four major moons of Jupiter: Io, Europa, Ganymede, and Callisto. Surprisingly, the Jovian moons show the same auroras seen at Earth's poles, which are caused due to oxygen molecules. However, since the gases on Jupiter's moons are thinner, the red color glow is intensified by nearly 15 times more than the familiar green one. Why does this story matter? It might be a lesser-known fact that the largest planet in the solar system is also home to stunning auroral displays like the ones on our home planet. In fact, Jupiter has the brightest auroras in the solar system. The occurrence of auroras on Jupiter was first discovered almost 40 years ago, in 1979, by NASA's Voyager 1 space probe. Observations were made when the moons were in Jupiter's shadow. The observations were made using the W.M. Keck Observatory in Hawaii, the Large Binocular Telescope in Arizona, and Apache Point Observatory in New Mexico. Astronomers observed the moons in Jupiter's shadow so that the aurorae, caused by the planet's strong magnetic field, could be spotted without any interference from the sunlight reflected off of their surfaces. These observations are tricky. Because in Jupiter's shadow, the moons are nearly invisible, said Catherine DeClaire, lead author of one of 2 new research papers published in the Planetary Science Journal describing the discovery. The light emitted by their faint aurorae is the only confirmation that we've even pointed the telescope at the right place, she added. How do auroras form on Earth and Jupiter? On both Earth and Jupiter, auroras are formed when charged particles like electrons interact with the planet's magnetic field lines, which then subsequently enter the planet's atmosphere, giving rise to the glow. On Earth, the most intense auroras are caused by solar storms, which are a result of high-energy particles ejected from the sun that make their way to the planet. Jupiter's Io moon also sparks auroras on the planet. When these particles enter the atmosphere, they interact with gases present there, sparking off red, green, and blue glows at the poles. Along with solar winds, Jupiter has an additional source for auroras: Io, the planet's innermost moon, known for its numerous and massive volcanoes. Io is known for its massive volcanoes. On Io, the volcanic plumes of gas and dust are so large that they can shoot hundreds of kilometers high. These plumes contain salts like sodium chloride and potassium chloride, which break down to produce multiple colors. For instance, sodium imparts a yellow-orange glow. The investigation also shows potassium auroras at Io in infrared light. This has not been detected anywhere else before. Auroral colors provide information on Jovian moons' atmospheres. What's significant about these findings is that they shed more light on the Jovian moons. The brightness of the different colors of aurora tell us what these moons' atmospheres are likely made up of, said DeClaire. We find that molecular oxygen, just like what we breathe here on Earth, is likely the main constituent of the icy moon atmospheres. Astronomers using W.M. Keck Observatory on Mauna Kea in Hawaii have discovered that aurorae at visible wavelengths appear on all 4 major moons of Jupiter: Io, Europa, Ganymede, and Callisto. Seeing Keck Observatory's high-resolution Echelle spectrometer, HIRES, as well as high-resolution spectrographs at the Large Binocular Telescope and Apache Point Observatory, a team led by Caltech and Boston University observed the moons in Jupiter's shadow so that their faint aurorae, which are caused by the gas giant's strong magnetic field, could be spotted without competition from bright sunlight reflected off of their surfaces. These observations are tricky because in Jupiter's shadow the moons are nearly invisible. The light emitted by their faint aurorae is the only confirmation that we've even pointed the telescope at the right place, says Catherine DeClaire, Caltech professor and lead author of one of 2 new research papers published today in the Planetary Science Journal describing the discovery.